Today we are going to be reviewing an Algebra 1 concept. We're going to be talking about solving linear systems by graphing. So we have three different learning goals, one for each example. Our first learning goal, I can determine whether a given ordered pair is a solution to a system of linear equations. So you can see the directions here say check whether the ordered pair is a solution of the system. And I'm sure many of you already remember how to do this. All you're doing is taking your ordered pair, and remember that every ordered pair has an x coordinate and a y coordinate, and you're plugging those values in to these equations over here. So I plug it into the top equation. X is 1, so 1 minus 3y. Y is 4. So I plug that in, equals, and that's what I'm trying to find out, does it equal -5? So 3 times 4 is 12. 1 minus 12 is certainly not -5. So this did not work when I plugged it into the first equation. If it doesn't work in the first equation, it doesn't matter if it works in the second equation or not. You don't even have to try it, because the only time an ordered pair is going to be a solution of the system is if it works in both. So has to work in both equations. So since it didn't work in the first one, that means that no, this cannot be a solution of the system. Yes, you do have to show me work on these. No more than what I just showed you, but you do have to show me that you plugged it in and that you know why it's a yes or a no. So why don't you try B, plug -5 in for your x, 0 for your y into your first equation. See if it's a solution. If it is, plug it into the second one and check it. And then unpause and see if you've got it correct. So in the first equation, got -5 minus 3 times 0 when I plug it in. And I'm asking, does that equal -5? 3 times 0 is 0, so that gives me -5 equals -5. So yes, it works in the first one. That does not yet mean that it's a solution. Again, it has to work in both. So now plug it into the second equation. So -2 times -5 plus 3 times 0, and I'm asking, does that equal 10? So -2 times -5 is 10, 3 times 0 is 0, 10 does equal 10, so I got something that works in both, so this one is a yes. All right, so hopefully you feel comfortable with that first learning goal. So let's move on to the second. I can solve a system of equations by graphing. We just reviewed a ton of graphing with the piecewise functions and with absolute values. So graphing a line should not be a problem here. But we have to remember that in order to graph a line, it's important that we put our lines in slope-intercept form. And the equations that I've got here are not in slope-intercept form. So that means I need to get them to look like y equals mx plus b. So all that means is I have to get y alone. That's why in the first section we practiced solving for variables when there was more than one, because you have to do this every time you want to graph a line. So in this top equation, if I want to get y by itself, the first thing I'm going to do is subtract the 2x. So subtract 2x here, subtract 2x here. Now, if we want it y equals mx plus b, that means we want the x term first. So -2y is what remains on the left, because these would cancel out. Then on the right side, these are not like terms. Please do not tell me that that's -10x. They're not like terms. It's just -2x minus 8. So now, to get y by itself, I simply divide everything by -2. So y is going to be alone. Y equals, then the -2 over -2 is just 1, so that's 1x. And then -8 divided by -2 is +4. So y equals x plus 4 is my first equation. So I'm going to go ahead and graph it on my coordinate plane. So I know that I'm going up 4 because that's my y-intercept. A slope of 1 means up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. You need to graph these lines until they go off the page. So make sure you cover the entire coordinate plane that you're given. Hopefully you connect your lines a little better than. Okay, so now we need to move on to the second equation. I'm going to use a different color so that we can see those equations stand out. So this equation on the bottom, I again need to subtract 2x from both sides. So that's going to give me 2y equals negative 2x plus 4, because these cancel each other out. And again, these are not like terms. You can't take 2x away from 4, not like terms, so they stay separate. So now I'm going to divide by 2. These cancel. I've got y equals negative 2 divided by positive 2 is negative 1, so negative 1x. So negative x, 4 divided by 2 is 2. So negative x plus 2. So y-intercept of 2, slope of negative 1 means down 1, right 1, down 1, right 1. Oops, went down 2 there. So ignore that last dot. It's not really there, but I can't erase it. Or up 1, left 1, up 1, left 1, up 1, left 1. So there's my line. Now, when we are solving systems of equations, whether we're doing it by graphing or whether we are doing it algebraically does not matter. The meaning is the same. When you are looking for a solution of a system, you are looking for the intersection point. So the solution is the intersection point. So the place where those two lines intersect is right here. So that means my solution is going to be negative 1, 3, the ordered pair. Now notice that the directions say then check your solution. This you do not have to show me work, you can mentally check it, but plug it in just like we did in example 1 to make sure that it's right. You shouldn't have any wrong answers, because if you get an answer and you check it and it doesn't work, that means you graphed something wrong. So if I plug in negative 1 for x and 3 for y, I get negative 2 up here, then minus 6. Negative 2 minus 6 is negative 8, so it works here. Down here, 2 times negative 1 is negative 2, plus 6. Negative 2 plus 6 is 4. So I just confirmed that it works in both equations, so this is my solution. Again, really important that you don't just watch and listen to me do it, that you are able to do it yourself. So B, please get the y's alone in both of those equations and then unpause to see if you've got them correct. So solve for y because we need y equals mx plus b form, and then come back to see if you got it right. All right, in the top equation, if I want to get y alone, the first thing I need to do is subtract the 4x on both sides. So minus 4x. Over here, those are going to cancel. So I've got negative 3y equals negative 4x minus 15. So now divide by negative 3. These cancel. So I've got y equals negative divided by a negative is a positive, so that's just going to be 4/3 x. Negative 15 divided by negative 3 is a positive 5. So that would be my first equation. Now again, I'm going to switch colors. My second equation, if I want y alone, I'm going to subtract x first. So these will cancel out. I've got 2y equals negative x minus 1. And I need to divide by 2. Now here is where people get all confused because there's nothing written in front of here. Remember that that's a negative 1. Negative 1 divided by 2 is just negative 1/2. It's showing you the fraction right there. So negative 1/2 x, and then again over here it's minus 1/2. So you've got your two equations. Now you can graph them. So I'm going to graph this one first since I'm currently on this color that I need. So negative 1/2 is my y-intercept. So I go down 1/2 to start. A slope of negative 1/2 means I'm going to go down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, up 1, left 2. So there's my first equation, my pink or purple, whichever you think it looks like. Now I'm going to my blue equation, y equals 4/3 x plus 5. So y-intercept of 5, so I start up here. A slope of 4/3 means up 4, right 3. I don't have room to do that, so it can also mean down 4, left 3. So I'm going to go down 4, to the left 3, down 4, to the left 3, and connect my lines. Now, I cannot use a straight edge on here, so you can. So your lines should look better than mine. And because my lines don't look so good, you can see the importance of using a straight edge. This one got a little off when I was connecting it. Those do intersect right here, but because I couldn't use a straight edge, it didn't look exact, and yours won't look exact either unless you use a straight edge to connect them. So there is my intersection point. The coordinates of that point are -3, +1. So that should be my solution. Again, don't forget to check it. If I plug it back in, 4 times -3 is -12, minus 3 times 1, which is -3. So -12 minus 3 is -15. So that works. Down here, -3 plus 2 times 1. Well, 2 times 1 is 2, so -3 plus 2 does indeed give me -1. So I've checked it. I know that my answer is correct. So that tells us how to solve a system of equations by graphing. Again, the solution is the intersection point. Never forget that, because that is the meaning of what we're doing, and it's important to understand why we are doing what we're doing. All right, so let's move on to our last example and last learning goal. I can identify and describe the conditions in which a system has no solution or infinitely many solutions. So, and you can either write it up here or you can write it down here. I would probably put it up here with your other information. So, the no solution. If our solution is represented by an intersection point, the types of systems that are going to have no solution is when there is no intersection point. So no solution means no intersection. Now, infinitely many solutions means there must be an infinite number of intersections. So let's see what those two situations could look like. So we start off the same way as we did in example 2. We need to get our equations in slope-intercept form. So on my top equation in example 3a, I'm going to subtract 2x first. These will cancel, so I've got 4y equals -2x plus 12. I'm going to divide by 4. y equals negative 2 over 4 reduces to negative 1/2. So negative 1/2 x, 12 divided by 4 is 3. So negative 1/2 x plus 3. My second equation, I would subtract x first. So that would give me 2y equals negative x plus 6. Then I would divide by 2. Y equals negative 1 over 2 is negative 1/2. X, 6 divided by 2 is 3. Now if you look at these two equations, they're the exact same equation. So when you go to graph it, doesn't matter whether I use red or blue, it's the same line. Has a y-intercept of 3, a slope of down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. Here is my line. Now, if I wanted to graph the red separately, it would be graphing right exactly on top of my blue. This is the situation where you have infinitely many solutions, because as you watched my red go right over top of my blue, everywhere it touches is an intersection. And so, because it's the same line, there are infinitely many intersections because the line goes on forever. So, that is how you know when you have infinitely many solutions, is if your two equations end up being the same line. So same line is what gives us infinitely many solutions. All right, last example here. So get it in slope-intercept form first. So subtract x, subtract x. So negative y equals negative x plus 5 is my first step. Then I need y, not negative y, so I need to divide everything by negative 1, which changes all the signs. So y equals x minus 5 is my first equation. My second equation, I'm going to subtract 2x first. So these will cancel. I've got negative 2y equals negative 2x plus 9. Divide by negative 2. Those cancel. Y equals 1x, so just x, minus, because positive divided by a negative is a negative, 9 over 2. 9 over 2 doesn't come out evenly, so leave it as a fraction. So here's one equation. Here's my other equation. If I go to graph the pink one here, negative 9 over 2 is negative 4.5. So a y-intercept here of negative 4.5 would be right here. A slope of 1, up 1, right 1, so on and so forth, all the way off the page. Or down 1, left 1. I'm going to try my best to connect this straight again. You can use a straight edge. The harder I try, the worse it is. All right, so we'll pretend. Use your imagination there. That looks nothing like a line. Sorry about that. All right, purple. It has a y-intercept of negative 5. So that means all the way down here, just a little bit first one. It also has a slope of 1. So up 1, right 1, all the way across the page, down 1, left 1. Now, if my drawing were better, oh, good grief. If my drawing were better, you could probably better tell what type of lines they are. Hopefully you've been graphing this on your paper as well, and if you look at your paper, you can actually tell that those graphs, they look like this. Those are parallel lines, and parallel lines you learned in geometry, stressed over and over and over again, they don't intersect. If there is no intersection point, there is no solution. So the type of system that is going to give you no solution is when you have parallel lines that never intersect. And that is all.